This is the next engine that I'm going to be building. There are 3 caps here, here, and here. These will be made on lathe. And then there's a internal aluminum cylinder. I might do 3/4 with a 1/16 inch wall, and then the outer will be the 1 inch that I'm using now. I don't really want to go any bigger than what I'm using now, but I can go smaller on the inside than the combustion chamber, and just maybe make it a little longer. We have a graphite nozzle, and then there will be some gasket materials coated in red silicone, both here and on the sides. The graphite nozzle transfers a tremendous amount of heat to the aluminum, and on the last test it caused it to fail. That and how it was attached just with the set screws into the aluminum was that was the point of failure there. So basically what we have here is there's this cap that goes inside the small diameter aluminum tube a little bit, and then there's an air gap, and then this larger aluminum cylinder goes inside or fits around the outside of this cap. So basically it holds these two together, and then there's another one here. The way that these are held in place is that there's a rod, a 6x32 steel rod that goes inside this channel, and then compresses all of these caps together. There is air gap around the cylinder too, where there's going to be 4 of these kind of placed in this kind of position. I don't know if you can see it, like that in the end. So in these spaces that there aren't these 6x32 rods, that's where the cooling can happen. The nitrous oxide comes in, cools the combustion chamber, comes through the back, and then enters the this nozzle here. It goes through the acrylic, and then reaction happens, comes out the end of the nozzle. So it's a regeneratively cooled rocket engine. The benefit of having the nitrous come down here is that the gimbal on the back, there we won't have to worry about how the gas line that comes in there is going to come through the gimbal, because I want this to just kind of be bolted onto the gimbal itself. So there's end cap, inside cap, exterior wall, interior wall, gasket, graphite nozzle, nozzle cap, another little gasket, and then the oxidizer inlet. So this is the micro hybrid engine 5th iteration. The nozzle design here is a 45-degree converging and then a 15-degree diverging. If you have any input on how exactly the geometry should be made, I'm not exactly sure how to get the calculations I need and where to put the calculations to design the perfect nozzle. So the nozzle design is something that is what I'm really focused on right now, and I do want just to have an engine that is pretty stable to be able to test that sort of thing, and then as soon as it's ready I can put it into flight.